We're going to be doing 2.14. Morning, Jonathan. Just let the guy in, William. Alright, let me go ahead and present my screen. Alright. So, Aaron, you can see my paper and hear me, obviously?
Yeah.
Awesome. All right. Well, let's get rocking. I'll give you like another couple seconds to make sure you can get this paper out. This should be the last like notes handout before, probably like a sample test. So let's do this. Hopefully this lesson won't take very, very, very long. Let's see here. Okay. All right, here we go. So we are just trying to roll on through and kind of figure out all these different ways of factoring. So this handout starts off by saying, like, so far, the methods we've learned to factor a polynomial include what? So like William, what method would we use on this 4x plus 10? If I said, let's factor this, what method would you apply? Do you think you know? Do you know what I'm getting at? I know it's a Monday, and you might not even know what I'm sort of where I'm going with this. But like, what method applies to this? Do you know, William?
No.
How about this, William? Do you know what what if I gave you a little hint and said, like, what method do we always try first? Does that help you at all? Or not really?
Not really.
Well, I guess one way to look at this is like, after we get done with this lesson, we'll pretty much have come like full circle with all this factoring. So you guys should have like the big picture, and you should, especially with doing these homeworks, and hopefully you're asking questions if you're having trouble, but you should have a pretty good idea of like the overall big picture of all this factoring. So there's the GCF method. If you can bring out a GCF from all the terms. Aaron, do you know the other method? Like, let's say GCF doesn't work, or you do bring out a GCF, but you want to like try to keep factoring if you can. What other method is there, Aaron? Do you know? And if you want to use these two polynomials as a hint, you can do that, because like it's the method you would apply to this, especially considering there's no GCF with x squared plus 9x plus 14. So Aaron, do you know what the other method we call? What do we call the next method? Do you know?
I don't know.
And I suppose a lot of teachers and textbooks are different, but the other major method is unfoil, okay? Because when you factor by GCF, like let's look at this one for example. The GCF of 4x plus 10 is just 2, and so you're factoring out that GCF of 2, and the other so one of the factors is 2. The other factor, like 2 times what gets you 4x plus 10. So the other factor is 2x plus 5. So when you factor by GCF, you're writing it as like a monomial times whatever. In this case, it's a binomial, But unfoil, you're writing it as a binomial times a binomial. And so far, and again, I hope you've been keeping track at home, you know what I mean? Of as we move from section 211 to 212 to 213, you know what I mean? What was, so 211, yeah, because section 211, I don't know if you want to write this down, you don't have to. I'm pretty sure section 211 was about GCF, and then we took section 212 and section 213 to talk about unfoil, because there was basic unfoil. This was basic unfoil. Dakaya, do you remember how we would do basic unfoil to this? Do you know what the two bubbles would be here, Dakaya? On something like x squared plus 9x plus 14? No? Well, again, I know it's Monday, but in theory, even though it's a Monday, even though whatever, in theory, we've done this kind of stuff, and so we're just trying to complete the big picture right now. But this basic unfoil is just when, oh my gosh, the bubbles are just going to start off with x and x, and I can just think of what two numbers multiply to make positive 14, but they also add up to positive 9. And long story short, that would be plus 7 and plus 2. Okay? Connor, Ellison, Jack. Connor, Ellison, Jack. Anyway, so that's what I would call basic unfoil, but it's unfoil. And if I wanted to factor something like this, 2x squared plus 9x plus 10, we would need, so we got basic, and then we got Phoenix method. Because when we do Phoenix method on this one, it's still technically unfoil. Okay? It's still technically unfoil. But I'm just trying to kind of give a recap here, because we're going to, again, this is the third time I'm saying this, but we're going to try to complete our big picture on factoring. So guess what? Unfoil, when I put this dot, dot, dot here, there's a little bit more to the story with unfoil. So again, so far we have basic unfoil, and then we have the kind of unfoil that we want to use the Phoenix method to get us. So in this lesson, we're going to do a little bit more with the unfoil method by looking at a couple of special cases. Here we go. Special case number 1. It's really not that special, and here's what's going on. It's called perfect square trinomials. Now again, I don't think this is that special at all, because let's look at this one. So Jack, this again, it always kind of boils down to the same overall strategy, which starts off as trying to do what? What's the first method we try, Jack? Always, no matter what. GCF. Is there one here? Nope, because we got to look at all three terms, Jack. Okay, I know you. I don't know if I kind of tricked you there with my tone, but yeah, don't let yourself get tricked. It's got to be all three terms, and so there is no GCF. Of course, other than one, which doesn't count. Okay, so there is no GCF. So our next plan is always unfoil. Okay, unfoil. And so here, look at this. Oh my gosh, it's just x squared. So it's just going to start off with x and x. So, Aaron, maybe I'll circle back to you. Do you think you can figure out what two numbers finish off these bubbles, considering we got to have like a 16 here and a negative 8 there? Do you know? What do you think? No rush.
Negative 2 and 4.
Negative 2 and 4. It's not a bad guess, but remember, Aaron, they have to multiply to make the positive 16, but they also have to, they add up to negative 8, not multiply. They multiply together to make the positive 16. Okay? So, again, like I said last week, a lot of you guys can do this very comfortably in your head, but you might have to go over here to like, so we got positive 1 and positive 16, but when we look over here, they got to add up to like being a negative 8. I think automatically we can already assume that it's got to be like a minus minus. If we're going to get a positive 16 here and a negative 8 there, it has to be minus minus. So how about minus 1 minus 16? I don't think that works. You know, how about negative 2 times negative 8? That gets me 16, but does that get me negative 8? No. So, man, Jesselyn, can you think of one more way that we can get a positive 16? Like, how else can we multiply to get a 16, Jesselyn? There's one other way.
Negative 4 times negative 4.
There you go. And check it out. When you add negative 4 and negative 4, you get negative 8. So there we go. We got it. So that was, hey, so that was basically still just basic unfoil, you know? And again, like if you can do this quick in your head, all the more power to you. But if you got to go off to the side here and like write down all this stuff before you find your answer, whatever. So this was just basic unfoil, okay? And the only thing that made this a special case was that we got the same bubble twice in a row. I don't even consider this that special. I don't consider it being that special. But it just so happens you get the same bubble twice when you do your unfoil. Like here, you look at this and you go, oh, let's try to factor this. And you look for a GCF, which there is no GCF. So you move on to unfoil. But when you see this 9 right there, you should start to think like, oh, I'm gonna need the Phoenix method, you know, because when there's a 9 out in front, or like if this first term is anything other than just x squared, the unfoil gets a little more complicated, and that's why I taught you the Phoenix method. So there's no GCF, so we move on to unfoil, but in this case, unfoil is going to mean the Phoenix method. Let's review these steps really quick. Multiply the 9 to that last number. So now we have x squared plus 6x plus 9. So we take that Phoenix number and we multiply the last number. All right, Lucas is here now. Lucas. All right, so the Phoenix method continues. Now we just look to unfoil it the basic way, you know, because now we just have x and x for x squared. And the two numbers that multiply to make 9, but they also add up to 6, is of course positive 3 and positive 3. So that's the next step in the Phoenix method. But then it's not done. Now we bring the Phoenix back to life. I hope this is ringing some bells, you know. That's the next step in the Phoenix method. After that, we look to reduce the fractions if possible. Turns out that both of these reduce to 1/3, and then the final step is to bump these denominators up in front of the x's, and that's the last step in the Phoenix method. So we're going to end up with 3x plus 1 times 3x plus 1. So again, that was just a Phoenix method example of unfoil, and the only thing that made it special is that it was the same bubble twice in a row, which technically now you can call this like a perfect square trinomial. Like this x squared minus 8x plus 16 is a perfect square because it was like this bubble squared technically. Like, you don't have to write this down, but I'm just trying to make my point. This was like a bubble literally squared. This 9x squared plus 6x plus 1 was literally this bubble squared, you know. And again, you don't have to write this down. You don't have to write this down when you actually do problems. I'm just trying to make my point here. Like, that's why we call this a special. It's so special, you know. But it's really not. You just unfoil the way you always unfoil, whether it's basic and you're done quick, or you got to bust out the whole Phoenix method. All right, next page. Trying to fast track this. Before we look at the other special case, let's multiply these and see what happens. So this, as you recall, is just distributive property. A lot of, like, we can call this FOIL. Like, this is actually FOIL, not unfoil, but FOIL. So x times x is x squared. X times negative 3 is negative 3x. And then now we distribute the 3. You know, we did the firsts and the outers. Now we got to do the inners and lasts. So 3 times x, that's plus 3x. And then positive 3 times negative 3 is negative 9. But Lucas, what happens before we can call this done?
I don't know.
Or do you think there's any like terms? Like, we already did all the multiplying. Like, we did the FOIL, we did all the distributing. But we always check to see if there's any... Oh, did you...
Yeah, you combine like terms like the 3x, and the negative 3x and the positive 3x.
Yeah, what do those add up to?
Just x.
Close. Not x, because that would be 1x.
Okay.
But negative 3 and positive 3, they don't add up to 1. They add up to, like, literally 0, like I'm sure you're thinking about. So guess what? That's gone. So in this case, the final answer is just x squared minus 9. And, you know, ... long story short, because of the way these two bubbles compare to each other, just x plus 7 and x minus 7, that same thing is going to happen. I mean, I might as well write it out really quick. Plus 7x minus 40. Sorry, that's bad. Minus 49. That's a minus 49. Okay, but that's what happens. You know, when you multiply bubbles like this together, like it even happens here. You know, because when you do the outers and the inners, you're going to get like a negative 10x. But then you're going to get a positive 10x. So in this situation, you know, you just kind of end up with like 4x squared minus 25. So here's what I'm getting at. Like, here's the bottom line. When you see something like x squared minus 9, or x squared minus 49, or 4x squared minus 25, this is actually what I would call a special case, because you have to realize that this and even stuff like this can unfoil. See, here's the challenge. Normally, things that unfoil have 3 terms. X squared plus 9x plus 14, 2x squared plus 9x plus 10. These other examples down here, x squared minus 8x plus 16. Normally, when you go to unfoil something, it's got 3 terms. But now, starting now, you have to be on your toes about looking at a binomial that might actually unfoil. The key is whether or not, underline this, whether or not it's the difference of 2 perfect squares. If it's the difference of 2 perfect squares, it can actually unfoil. Like x squared minus 9 can unfoil to be x plus 3 times x minus 3. Because x squared minus 9 is the difference of 2 perfect squares. You know, x squared is a perfect square, and 9 is a perfect square. And this minus means it's the difference. Again, it's got to be the difference of two perfect squares. All right. So let's go to Jesselyn. Okay. X squared, is that a perfect square, Jesselyn?
Yeah.
Yep, you're right. Is 36 a perfect square?
Yeah.
Yeah. Jesselyn, what's the square root of 36? Like, what's its perfect square root? Like, what number times itself is 36?
6.
Yep, perfect. And so you look at this, and here's your line of thought. Okay, let's run through that really quick. Obviously, when you look at that, and I'm telling you to factor it, you're going to check for a GCF first. You always check for a GCF first. There isn't one, other than one, doesn't count. So there's no GCF. Then you go like, okay, but the only other method is unfoil, you know? And again, now you have to train yourself to go like, but this is just a binomial. So the only chance that this has to unfoil is if it's the difference of two perfect squares, which it is. And so Jesselyn already, so you put x and x, and then one bubble is plus, one bubble is minus, and whatever the square root of 36 is, that's what goes in the bubble. So your bubbles are x plus 6, x minus 6. And that's how simple this is, as long as you know what you're looking for. N squared minus 1. There's no GCF, and you try to unfoil it, and the only way this unfoils is if it's the difference of two perfect squares, which it is. The square root of n squared is n. So that starts each bubble. The square root of n squared is n. The square root of 1 is just 1. So the bubbles are n plus 1, n minus 1. That's how this works. One bubble's plus, one bubble's minus. And again, if you ever want to convince yourself like why that's true, then analyze. See up here, that's why we did this. That's what happens with FOIL. When you have bubbles just like this, x plus 3, x minus 3, these two terms are going to cancel out. It's just the way it goes. And so you end up with a final answer like that, which, again, you got to remember how that can reverse engineer, though. So number 3. Let's see here. Connor, is there a GCF to 4x squared minus 81? Because we always check for a GCF, Connor. Is there one?
Not that I found.
Good. So do you think 4x squared and 81 are both perfect squares, Connor?
Yes.
Yeah. What do you think the square root of, so, okay, plus minus. What's the square root of 4x squared, Connor?
2x.
Very good. How about 81?
9.
9. So guess what, people? It's that quick and simple as long as you know what you're doing. Again, no GCF, so you move on to unfoil. But again, it's a binomial. The only chance this has to unfoil is if it's the difference of two perfect squares. And you put the perfect square roots in your bubbles with a plus or a minus. Next one, Aaron. Is there a GCF?
No.
Nope. So let's see if this is gonna. I think I made my bubbles too small, but whatever. Does 9x squared and 16, Aaron, both have perfect square roots?
Yeah.
I agree. So how about, so what starts off each bubble, Aaron?
X or 3x?
3x, good. 3x times 3x is 9x squared, and then how about the square root of 16, Aaron?
4.
4. So 4 goes there, 4 goes there. 3x plus 4 times 3x minus 4 will FOIL together to ultimately end up with 9x squared minus 16. I'll handle number 5 really quick. Now, you look at this and you might like automatically think, oh my gosh, there's a perfect square root to 4x squared and 36, but don't forget to always do GCF. William, there is a GCF, so we have to do it. So what is the GCF, William? Do you know?
4.
Nice. So, all right, don't forget that, people. So what's going to be left over in here is x squared minus 9. Now, plot twist. You got to remember that whenever you take out a GCF, you always got to try to keep factoring. X squared minus 9. Jonathan, x squared minus 9. Can this keep factoring, you think?
No.
Actually, it can. Because again, remember, the only other method is unfoil. It's unfoil, right? We already did GCF, so but when you look at x squared minus 9, you got to remember that starting now, you look at that and go, well, it's only a binomial. There's only 2 terms. The only way that's ever going to unfoil is if it's the difference of 2 perfect squares. But it is, though. X squared and 9. So we're talking x plus 3, x minus 3. So you guys got to be on the lookout. And again, I'm totally going off on it. So you don't have to write this down if you don't want to. But you got to be looking for things like x squared minus 25, x squared minus 36, x squared minus 81, 4x squared minus 1, because 1's a perfect square, and 4, or x squared minus 16, or x squared minus 49, you know what I mean? Like, you got to know your perfect squares almost by heart, I suppose. But anyway, number 6, last one. Is there a GCF, Dakaya? Because we always check for a GCF. I mean, heck, 50 is not a perfect square anyway, and 8, but we always check for a GCF first anyway. So what do you think, Dakaya? Do you think there's a GCF? No? I think there is. At the very least, it's 2. But I mean, like, could it be 8? Does 8 divide also from 50? No. How about 4? Like, I don't just want to go with 2. It might be 2. But I want to check whether it's 8, which it's not. But it also could be 4, right? Does 4 divide out of 50 cleanly? I don't think it does. So I guess it's 2. I guess it's 2. So, Jesselyn, what's left over if we divide a 2 out in front as a GCF? What's going to be left over in the bubble here, Jesselyn?
4x.
4x squared, good. How about from the 50? Very good. Nice job. Jack, can this keep going now? Can we actually unfoil the 4x squared minus 25?
No.
Yes, because they're both perfect squares, right? As long as it's the difference of 2 perfect squares, you can. Jack, what's the square root of 4x squared?
2x.
How about 25?
5.
Yeah. So the 2 comes down. Don't forget about the 2. And then the bubbles are going to be like kind of what Jack said. 2x plus 5, 2x minus 5. So now you guys should have like the full picture about how there's GCF. You always try GCF. And then, plan B is unfoil. But unfoil to me means like there's like basic unfoil, there's Phoenix method level unfoil, and there's difference of 2 perfect squares unfoil. Again, I don't even really consider this like that, like its own special case. You know what I mean? So your homework, I assume your homework is handy. So for example, like number 1, you're not even going to look at that as like a special case. You're going to go like, oh, there's no GCF, so let's just do like basic unfoil, And And Lucas, when we do basic unfoil to this one, what are the two numbers that multiply to get 25 but also add up to 10?
5.
Yeah, 5 and 5. So that's, in my mind, that's just basic unfoil. You know what I mean? But when you get down to like number 13 or number 14, or holy crap, number 15, someone help me out, like, because I'm assuming now that 196 is a perfect square. Connor, is there a perfect square root to 196? There has to be. Otherwise, this isn't going to factor at all. There's no GCF, so the only hope is whether, if that's a perfect square. I think it is, but do you know what it is, Connor?
Might be 13, but I can't really say for certain.
I don't think it's 13. It might be 14. See? Hey, gang, that's why everyone, including me, has to have a calculator handy. I want to say it's 14, but it might be 16. I don't think it's 16. If it's not 14, it's 16, but it's 14. So again, difference of two perfect squares. A lot of these are differences of two perfect squares, but don't forget to try a GCF first. Like down here with the with number 22, you gotta check for a GCF first. There isn't one, but this is the difference of two perfect squares. So it'd be like 5x and 3. So plus 3 minus 3. Let's check on the back to see if there's any tricksy ones of your homework. Again, just always make sure there's no GCF. Like let's look down here at number, oh my gosh, these are some big numbers. But in number 28, I'm going to go ahead and say that there's no GCF. But like in number 31, guess what? In number 31, there is a GCF. Okay? But this keeps going, doesn't it? This one keeps going. Check it out. Number 34 or number like 35, there is a GCF. So keep this in mind, people. There is a GCF, I think. Let's see. There is a GCF there. There is a GCF there. There is a GCF there. Yes, there is here. But again, just like number 31, you would bring out a GCF and then probably factor again. Number 36, yes. Yeah, there is a GCF. There is a GCF. There is a, right? Correct me if I'm wrong here, but yeah, there is a GCF. But anyway, that's it for today. If you're confused about any other homework or what we just talked about, then stick around for sure. But otherwise, I will see you on Wednesday.
See ya. Have a great day.
You too.
Thank you. I was wondering if I could have the topic review something for today.
Yeah.
I just came in a few minutes late.
So, like I said, I turned my camera back on, right? Or not back on, but. So, what do you mean by like how? When did you start? Like with these examples, or?
Yeah, I just need the top part.
Yeah, the top part was me just kind of doing a quick review of like you don't have to write. I mean, whatever. But we got GCF was the methods we've learned so far, and then we had already kind of learned that there was basic unfoil, and there was Phoenix method like level unfoil.
Yeah.
So like this one would be something you would do a GCF on. This one would be an example for like basic unfoil, and then this would be a pretty good example of like you would need to do the Phoenix method to do that unfoil. But Yeah, that was it. And then over here, I think I was just talking about how like this was section 211 for us, and then section 212 and section 213 was like referring to our notes, I guess.
Okay.
Basic on.
Thank
Yep, you're good.
you. Yeah, have a great day. I'll see you Wednesday.
All right, see ya. Bye bye.
Bye.